Hola, SAP developers. Welcome to this session, part of the TOEFS 2023 integration track. This is a session that I'm very excited about, all about event-driven architectures. Today, we have Christian from Solus and my colleagues Florian and Paolo, who will be telling us how we can achieve a scalable architecture by applying principles of event-driven architectures. Without any further delay, hola, Christian, Florian, Paolo, over to you.
Yeah, thank you very much. Hello, everyone. My name is Paulo Sviglio. I'm a senior development consultant at SAP, and my main focus area are application development on SAP Business Technology Platform and S/4HANA. So I've, for example, worked in several projects with CAP, the Cloud Application Programming Model, as well as RAP, the RESTful Application Programming Model. Over to you, Christian.
Hi, everyone. So just quick explaining why Florian isn't here today. Unfortunately, he wasn't feeling too well today, so he couldn't join us today. But Paulo and I are here to cover this call, this talk for you. And quick word introduction about myself. So I'm a Solus Distinguished Engineer. I work with Solus, who is a technology provider underneath Event Mesh and Advanced Event Mesh. And I've been a developer for a number of years when I started out in my career, and since then kind of moved on through the pre-sales engineering role and now into the partnership role supporting SAP on this product. So pleasure to meet you all. And yeah, without further ado, we'll start with the session. So by the way, if you have any questions, please feel free to drop them in the chat. Ask us anything you want. We'll try to get your answers towards the end of the session. So we have roughly a three-part schedule here today. So I'm here to talk a little bit about event-driven programming and event-driven architecture and the benefits of that. And then Paolo will walk you through the RAP programming model and do a demo on that and show you how you do event-driven with S/4HANA. And then we have roughly 15 minutes at the end reserved for Q&A. So that's why I say please feel free to ask your questions and we'll get those covered. Okay. So maybe a couple of words around the background, on the history of why do we talk about event-driven architecture. It seems quite a popular topic these days. And some of the driving forces behind that is maybe some people who have been working in this field as long as I have remember the mainframes and have worked on the mainframes. That was kind of the past, right? That is where a lot of companies and IT developers started out on. They had everything on one blade. It may not have been a mainframe. It might have been a large Unix server or Windows server or whatever other operating system you were using, but it was all on one blade. And everything you were writing, all the programs you were writing, they were communicating in memory, and it was all happening within that one box. And for a number of years now, almost decades, I'd say, we've been moving away from this type of architectures to more distributed architectures, right? So our customers have been adopting hybrid cloud, multi-cloud. They have been moving away from those large servers onto more distributed architectures. And at the same time, software has become more distributed. So those large monolithic applications that were built for the mainframe and similar servers, they were being broken up into smaller and smaller parts to make the architecture more scalable so that you can scale individual parts of your software without having to just add more RAM, add more memory, add more CPU on the big one box. You could scale things individually, right? So that's where we are. We have moved at the same time as these factors came into play into more distributed systems that need to communicate with each other somehow, right? So previously you were doing this through memory, through API calls, just invoking another function, another procedure that was running on the same blade. Now we have to do it somehow different. If we think about event-driven software design, there's one pattern that has been used for quite some time that has already been used in these large monolithic architectures, and that is the observer pattern. And with the observer pattern, anyone who's developed model view controller type systems, they know that you don't want to call for the changes on the object in the background constantly, because that is kind of slow. So you implement model view controller and the observer pattern, and whenever something changes on the data in the background, then the observer knows all the parts of the system that need to be updated and has a list of these systems, and it pushes those updates down to that system. So that is a one pattern here that is very similar to what I'm going to introduce now with the event-driven architecture. So keep that in mind. You probably have used this already if you have been developing for some time. Another important pattern with event-driven software design is the Reactor pattern, and that is mostly on the consumer side. So when we're talking about event-driven architecture, the parts of the system that need to be notified about the changes, they might get a lot of requests coming in, and they need to handle all these requests and then start some processing. So there's this Reactor pattern that makes this really easy, scalable. So one tight loop that is handling all the requests and then spawning off worker threads on the consumer side. This is not going to be relevant to the RAP programming model today, but I just wanted to mention it because a lot of the APIs that you might be using to connect downstream systems that might be receiving S4 events might be using some of these APIs to connect to systems like Event Mesh or Advanced Event Mesh. That's important then when you're building on the other side. Okay, but let's talk about event-driven architecture. So when we have those very distributed systems, they couldn't be distributed across multiple sites. They can be on different software program languages, different operating systems, and they all kind of like need to exchange information with each other. And you can do it all point to point by invoking APIs or building replication flows between one system and another. But that is quite static in the way once it's set up. Like if you want to add another system, you have to then build another pipeline, so to say, to get the data from A to B. So there's a lot of coupling involved when you're building these architectures. And event-driven architecture is an approach to add a bit more decoupling to that picture. So we'll get to the details of how that looks like, but in the essence of event-driven architecture is the publish-subscribe pattern. And if we think about back to the model view controller model, you'll find it looks kind of similar. So there's a part of a system that has an update to its data, and it sends a message. And then this message is sent to a topic. And you will have multiple consumers that are subscribed to this topic that will get the data. So similar to the observer kind of like pushing that change to each and every part of the subscribed systems, we have now a broker that is managing a topic, and the broker then pushes that data that is published on that topic to all the consumer. So one of the key differences here is that it's not all in one system. It's not one software program. It is actually multiple parts, right? So the producer can be one system. The part where the topic resides is the event broker. That's another system that is probably on different servers. And all these consumers can be on different servers. They can be even on different data centers. So yeah, much more distributed. And the other important part is that the broker or the producer here in this case doesn't need to maintain the list of who is interested in the data, like in the model view controller model in the template. Instead, you just have a matching of a topic to a subscription. So whenever a producer sends a message or data to a topic, then there's some matching happening on the broker that will then route it to any subscriber. So we can have subscribers coming and going, and the producer doesn't need to be worried about that because he doesn't need to maintain a list of who gets the data. That is all done in real time at execution on the broker. Okay. So, and when we look at this architecturally, with event-driven architecture and specifically with the advanced event mesh, we can have brokers deployed in multiple sites. We can connect these brokers together, so they form a uniform layer that can transport the data. It's almost as if all these brokers that form a network of brokers, they act as if they were one. So you can connect the system to any of these brokers, be it your S4 system or another system, publish an event, and if there is anywhere in this network of brokers a subscriber that is interested in this topic, in this data, then the brokers will forward the data from the one broker that it's published from to any other broker where there might be a consumer and hand it over to the consuming application. So that's the mesh concept, and that is what's implemented with the advanced event mesh and makes this highly distributed architectures very easy to build and more decoupled. So some of you may think this looks a little bit like the ESB style architectures we've had in the early noughties already, and I've worked on some of these architectures. So the differences here is that it's really a distributed broker. So instead of having a central broker in a central place that oftentimes might become a bottleneck if there's a lot of data that needs to go through, these brokers are really a distributed set of brokers. So you don't have one single broker that everything has to go through. Like the data will just get routed through the brokers where the consumers are attached and where the producers are attached, and any other brokers that are part of this mesh network but don't have any producers, consumers won't see the data, right? So it's highly optimized to transfer the data just to the place where it needs to go, and therefore it is a more scalable architecture. Okay, so it's worth kind of summarizing the 5 key elements of an EDA strategy and the benefits of that. So one key aspect of why a lot of businesses are adopting EDA is that you get real-time data distribution, right? So one change happening in one system can be pushed out from that system and distributed to other systems in real time. And that is often done to gain operational insights in real time or to improve customer satisfaction and experience, right? So customers are used to having a real-time experience on mobile phones, getting push notifications when their orders are shipped, when the order is on the way, when the order is 3 stops away and things like that. And this is all being made possible through event-driven architecture and being able to push a change that is happening in one system to other systems in real time. Another aspect is that this is all based on the pub/sub model and that it allows fan out of data. So if that one event, that one update needs to go to just one system, that is perfectly fine, that can happen. But if you have a second system that suddenly needs that data, you can just plug it in, you can just subscribe it to the topic, and it will get a copy of the data. So without having to change the systems that are already communicating with each other through the brokers, you can just add other systems or remove systems and no one else gets affected. So it's highly decoupled, and it cuts down on development time and cost because you don't have to implement another API call, open firewall rules, and so on and so forth. You just plug in the new system and the rest stays unaffected. It's also using what we call dynamic routing. So when you're publishing to topics, you can attach metadata to those topics, and that helps applications filter to get only events that they want to consume. So rather than having to browse through a lot of events that might not be relevant to them, they can set filters and just receive the parts that they want to receive. And that same filtering technique is also used within the broker mesh. So the brokers really just forward the data that is matched, and it's highly dynamic, and it helps reduce the load on the network, obviously between the brokers. They're not just sending the data that is required to be sent, but more importantly on the application side, on the consumer side, because you're not sending a lot of data that you then have to read through, parse, so that's CPU intensive to just discard it if it's not relevant to you. You just get the parts that are relevant to you. The application can use that CPU time for other things and not be bogged down by having to parse through irrelevant data. Yeah. one of the, I think, most important aspects of EDA is that it allows us to integrate systems in a very decoupled way. So systems don't have to be online at the same time. They don't have to be in the same data center. They don't have to know the URL of each other. All they need to know is where's my closest broker that I need to connect to, and what is the topic that I'm publishing to or that I'm subscribing to. And everything else is decoupled. So we're not coupling uptime of systems with each other. When you're sending a request for customer data from one system to another, that system can be offline and respond later, and you'll just get that response later. It doesn't have to be online at the same time. You can go at different speeds. The brokers will help you smoothen out any spikes and deliver them to downstream consumers at a speed that they can handle, and so on and so forth. So it really enables what I'd like to call a plug-and-play architecture for higher agility. It allows you to make changes in your system landscape more easily, because a migration of one system from on-prem to the cloud, if all the interfaces are communicating via topics and event-driven architecture, that means that you don't necessarily have to touch all the other communication partners as you would if it were via a more direct communication way. So because of the mesh concept, you can just move that system from on-prem to the cloud, and then it can keep publishing to the topics that it was publishing before, and the other systems don't necessarily need to know about that change. So gives you higher agility in doing innovation. And lastly, because it is so decoupled, you need a little bit of tooling around that. It's advisable that you have something to manage your events, an event management capability, something to catalog your events, so you can look up who is publishing events that you might want to subscribe to if you're building a new application. But also, if you are the one that is publishing events and you need to change something in the data structures that you're publishing, then you might want to notify the applications that are consuming those events. And event discovery, event management are usually, it's a concept of tools that help you manage that type of architecture. Okay, I think that was almost my last slide. This is my last slide. Yeah, I just wanted to mention a couple of other concepts that often get mentioned together with event-driven architecture. So some of the related patterns are deferred execution. Because systems don't need to be online at the same time, you can send a command from one system to another and it just gets executed later in time. So that is something to get your head around when you're doing event-driven architecture. Also, eventual consistency. You're pushing a change from a source system to an event broker, and if all the downstream systems are online and consuming, they will get that update in real time. But sometimes systems aren't online, or sometimes networks are congested, and eventual consistency just means that those changes that are propagating through the event-driven architecture, they will eventually reach all their target systems, right? So you just have to think about that when you're publishing events, that it might not reflect immediately in real time, but it will eventually reflect it on the other end. Oftentimes, I get asked, what about orchestration on event-driven architecture? So when you're doing RESTful calls, you often have an orchestrator in the middle. You can kind of do this with event-driven architecture as well. You can have an orchestrator microservice that is listening to events and then sending kind of like sub-events to individual components to orchestrate something happening. But more often, we have an choreography happening. So systems are just listening in on the events, like a beat that is happening, and then they're just reacting to what is happening instead of being orchestrated by a specific central component. The event mesh is a concept of a distributed network of brokers. Already explained that, and event-driven architecture is obviously part of this event-driven design, and I've explained that as well. So I think, yeah, that was my last slide. So I'm going to hand it over to Paolo to take us through the wrap approach and show us how that works actually in real time.
Perfect. Thank you, Christian. All right, before we will start with the demo scenarios, I just want to point out that this session is mainly not a training. Rather, our goal is to provide you with an overview to show you what is possible and to inspire you. And I'm probably also going to rush through the different demos due to time reasons and because I want to show you as much as possible. Nevertheless, Christian and I will also provide you with an extra slide with further reading material, which you can then use to deepen your knowledge. And of course, you can contact us in case of questions. And the demos I'm going to show you are done in RAP. So RAP stands for RESTful Application Programming Model. And if not done yet, I definitely recommend to get yourself familiar with this framework because you can benefit, for example, from a lot of out-of-the-box functionality. For example, it comes with a draft concept. Also, when you want to expose capabilities of a business object, it's also very easy to do this in RAP, for example, via the data protocol. Or if you want to follow the clean core strategy of SAP, you will also come across RAP. And as you can see in this session today, you also need RAP in case you want to define native events in an S4 system. So let's check out our demo landscape. On the left-hand side, you can see an SAP S4HANA system. I'm going to use an on-premise system version 2022. And on the right-hand side, of course, we need SAP Business Technology Platform. You need to make sure that you have the corresponding entitlement, and then you can create an instance of the SAP Event Mesh service. The service actually comes in two flavors. So there's a lightweight version, which is called SAP Event Mesh. And then there's a more advanced version, SAP Advanced Event Mesh, which comes with advanced messaging and monitoring capabilities. And there was also already a question in the chat if you can directly connect the RAP native events to SAP Advanced Event Mesh. The answer is no, at least not with S4 2022. So that's why I'm also going to use the lightweight SAP Event Mesh service for my demo. Nevertheless, with the next release, so 2023, it's also possible to directly connect the custom RAP events to SAP Advanced Event Mesh. All right, in total, I'm going to demonstrate 3 demos. So the first one will be an outbound scenario for standard events. So that means SAP delivers with S4HANA standard business objects, and they might come also with some standard events. For example, in our case, for the demo 1, we want to use a standard Fiori application to change a purchase requisition order. And whenever we change a purchase requisition order, we want to send an event notification to our SAP Event Mesh instance. And for that, we need a channel. And a channel connects our S4 system to our SAP Event Mesh instance. And for that, you need to create so-called service key, which are actually auth credentials, and we can use them to create a channel. After a connection was established, we can then start to configure the inbound and the outbound events. So by default, nothing is sent out and received. You need to configure them. The second demo will be also an outbound scenario, but this time a custom event. And this is also where the RAP comes in. So we will use a very simple sample application, which is based on RAP. And here in our behavior definition, we will then define a custom event in RAP. And you can see that there's also a new development artifact, which is called event binding. And the event binding connects our custom event to the S4HANA event infrastructure. And it also allows us to use our custom event for the configuration of our channel. And what you can see here in the brackets is actually the final topic of our custom event. And this final topic is also defined in the event binding. And you will see this in a minute. And last but not least, I also want to show you an inbound scenario. So this means now everything is vice versa, and the S4 system does not act as a publisher, but as a receiver, as a subscriber. So we want to subscribe to a specific event from to SAP Event Mesh. And whenever an event notification is received, we want to execute some business logic. And therefore, there's a concept in ADT that you can use a wizard to create a so-called event consumption model. And every event developed, for example, with the SAP BTP ABAP environment or with S/4HANA public cloud or on-premise, does also has an event specification file. And this metadata can be used in the wizard to automatically generate the event consumption model and the corresponding development artifacts. That means as a result, we will have an ABAP class with a corresponding method, which is triggered whenever we receive a certain topic. And then you can put your ABAP logic into this one. So these are the 3 demos. And as you can see, I'm only working with the SAP S/4HANA system. So normally in a real world life scenario, you could also have here, for example, a third-party solution. You could have another S4 system, maybe public cloud. You can also have applications developed with CAP or with RAP on BTP, and they can all act as publisher or as subscribers to SAP Event Mesh. All right, then let's start with the first demo, the outbound scenario with standard events. And first of all, the question is, how do you know which standard events are available in your system? And of course, the answer is that you can go to the SAP Business Accelerator Hub. So the URL is api.sap.com, and you can here browse your product, go to events, and you will find a catalog of all the events which are available in your product. And in our case, it will be the purchase requisition events. You will get a full documentation and details of what operations are supported. So you can see that we will get notifications, or we can get notifications for create, change, or approved operations, and so on. And you can see of each event the topic name. For example, this is the one we are going to work with. And you can also see how does the payload look like. In our case, for the event notification, simply the purchase requisition ID is passed. But we could also see that, for example, for children's, like items, there are also events, for example, whenever an item gets approved. And the last thing which I would like to show you here in the Business Accelerator Hub is that for every event, you get also the event specification. So I mentioned some metadata which you can use for the wizard in ADT to generate the event consumption model, for example. And here you can find this metadata document. All right. So now we have actually identified our topic. And the next step is to configure the channel. So let's jump into our S4 system, into ADT. This is the S4D system I'm going to work with. And we are going to use a transaction for the configuration /iwxbe/config. And in our case, for the demo, I already created the corresponding channel. In your case, what you would need to do is, again, you need the entitlement on BTP. You need to create an instance of Event Mesh. And then on the SAP BTP cockpit for your service, you need to create a service key, the OAuth credentials. And then you can actually simply click on the create button via service key, and you can paste your service key inside this text area, click on save, and the channel will get automatically generated, as you can see here. After the connection is established, you can start to configure your outbound and inbound bindings. And demo 1 will be outbound. Let me open this again. So this is my channel. Demo 1 will be outbound. And you can see that I already added the corresponding topic name. The purchase requisition changed. And here, of course, you could start adding further topic names, and you can see all the standard and custom events which are available in the system. So for example, let's get back to the purchase requisition event. And we have seen that there are also some items. Let's try if we can find it. And you can see that this topic name is indeed available in the system. But in our case, we are not going to use it for our demo. The ones which we need is already added, the first one. All right, and this is actually the time where we can use our standard Fiori application to change a process requisition and then see if something will be sent to our message broker. And as I said, I do not have any consumer, but Event Mesh comes with a cockpit and there is a test client. And this is what we are going to use. So on the cockpit for SAP Event Mesh, I define 2 queues. And for my second queue, if we check the queue subscriptions, we can see that I subscribe to the purchase requisition change event. And here's the test client I talked about. So we can check our Q2, and here we can consume messages and see if something is in there. All right. And this is the Fiori Launchpad of my S4 on-premise system, and this is the standard Fiori application app. And let's go to any purchase requisition. Let's simply click on the edit button. And for example, we can change the header node. We will remove the one. We will click on save. And now, because we configured our channel and we identified the topic name, an event should be sent to SAP Event Mesh. And therefore, we can use the test client and see if we received something. So I will click on consume message. And we can see, as we have seen in the Business Accelerator Hub, the payload is the purchase requisition ID. And this is exactly the one which we changed. All right, that's demo 1. We will now continue with demo 2. And demo 2, again, is also outbound, but this time it's a custom event. And we can see that now we are working with custom or with an application based on RAP, and that we also have a new development artifact, the event binding. So let's jump back to ADT. And I already prepared a package for the outbound scenario. And I can already show you my final application. We are going to use the preview functionality. So this is a very basic and simple application, which we can use to create some items. We can now have a look to the behavior definition of our interface view, so of our custom business object. And here is the event statement I was talking about, which is new in RAP or available since 2022. And we can use it to natively in RAP define custom events. So this is the event statement. This will be, or this is the name of my custom event. And in the payload, always mandatory is or are the keys of the business object. And in case you want to enrich this payload, you can use an abstract entity and use the parameter statement. So in my case, we can jump into it and we can see, okay, I also want to enrich the payload with item data. Let's go back, and actually that's it for the definition. Then I also created an event binding. And if you remember, I also said that the event binding is also responsible for the final topic name. So here you can see 3 fields, the namespace, the business object, and the business object operation. Actually, they are all free text, and you can fill them out. And as a result, you will get a type, the concatenation, and the type will actually be your topic. So this is the final topic of your custom event. And then you can map it to your custom event, which you created in your interface view. So you have here the root entity name and the entity event name, which I used in the behavior definition. And now the last step, again, of course, is to configure our channel. That's already done by me. To quickly show you that, again, we can go to our channel, go to outbound bindings, and you can now see the topic name, which we defined in the event binding. And now we defined our event and we configured it in the channel. But what is missing, that we are actually firing the event. And this can happen at several places. What we recommend, for example, to do it with an additional save in the save method. But what you could also do is, for example, to develop a static method and then call the static method. So inside the method, you will fire the event and then call it from outside your RAP business object, even with legacy code. So that also works. And in my case, we can go back to the behavior definition, go to our implementation class. And here for the save modified method, we can see on line 14 that we are raising our custom event, which we have defined. So again, this is like my business object, so the interface view. This is the name of the custom event. And then we can see the payload. So mandatory is always the key. And then because I use the parameter statement with an abstract entity, I also want to enrich the payload with the item value. So let's try that out and see how it works. Maybe first of all, I will shortly also go to event mesh. And under the queues, I also have a Q1. And here I subscribe to my custom event. So again, we can go to the test client, go to Q1, try to consume something. Oh, I think there was already something in the queue. Let's see. Okay, now it's empty. And now we can go back to my application, click on create. Let's say Oktoberfest 2, for example. Click on create. And we can now go to the event mesh client, click on consume message. And we can see the ID, the key of my business object, and also my abstract entity, the value, so the Oktoberfest 2, which I entered. All right, that's demo 2. And now let's, last but not least, continue with the demo 3, which this time is an inbound scenario. And normally what we would need is another publisher, for example, a CAP application or a RAP application, who would publish something, and then from the S4 system, we want to receive it, to subscribe to it. However, because I do not have any other publisher, in the demo 3, I will do both. I will use the S4 system to publish my custom event, and at the same time, I'm also going to retrieve it with my event consumption model. So first, I'm going to show you the inbound scenario. And for example, what you can do here is you could create an event consumption model, and that is the wizard I was talking about in ADT. And for example, here you can browse to your event specification file. That was already done by me. And as a result, we have we get an ABAP class. And in this ABAP class, there's one method which is listening as a subscriber to my custom event based on the event specification. And what I now need to do is, again, to configure the inbound events. So we actually want to listen to this event. So we will go to inbound this time. Create a new entry. Also shortly create a destination. And save the entry. All right, and we can now also use the debugger. So again, this time I will create a new entry. So let's go back. Let's say new entry. Click on create. And first, I'm jumping to my additional save implementation where we are going to fire the event. So we are going to publish it. So I will click F8 now. And now I'm jumping to my event consumption model. So this is the method I showed you. And for example, if you click F6, We can also go to the business data. And we can see again the order UUID, but also the item, the new entry. All right, these are the 3 demos. And as promised, Christian and I provide you with an extra slide with further reading material. So also from product management, I'm not part of product management, but they created also a lot of SAP blog posts with a lot of expert information. And yeah, here's a small extract of the most important links. And yeah, feel free to use them. And hopefully we inspired you with also the demo. And yeah, feel free to deepen your knowledge. All right, then I would say back to you, Christian, or actually I would say, I think we are now in the Q&A session.
Yep, exactly. Okay, yeah, so maybe you want to stop sharing the slide, Paula, so people can see us a bit better. Yes, there's a heated debate almost. There's lots of questions coming in, and I try to answer some of them on the fly, but I think some of them will need some explanation and a bit more context around them, right? So maybe we'll just go through them one by one and tackle them and see what we haven't answered. Okay, so let me see. So
maybe
there were questions.
Maybe I can grab one, so I also have opened a live chat. There's one question: will custom RUP events be fully supported in S4 Cloud? So I mean, that's mean public cloud, and the answer is yes. There might be some differences with the configuration. So what I showed you was a SAP GUI transaction, and of course in public cloud or also with SAP BTP ABAP environment, you will have corresponding Fiori applications to do the configurations. So there might be some small differences, but the principle and everything is the same. So the answer is yes.
Yeah. There's a lot of questions around connectivity to event mesh and advanced event mesh, and also some questions around Kafka. So I'll try to summarize it a little bit. I have given some more detailed answers to specific questions, but generally speaking, S4 notification events happen around for some time. They're just small notification events without much payload, and they have always been able to send to event mesh, right? The RUP-based events are something that are fairly new, that have only been introduced last year in the 2022 release, if I'm not mistaken. So that initially went towards event mesh as well. And now both of these will be able to send towards advanced event mesh with the coming 2023 release. And that then applies to the cloud release as well, going forward, right? Now, whether that is going to be the state, or whether that's going to change, that's a discussion that if you're interested in that, you should have with your SAP product management contact, because neither Paolo nor I are SAP product management, although I do have some contacts there. But there may be, if you ask them, then maybe there are some news there. Maybe that might change, but I can't promise anything. So just an indication, you should have a chat with them on that. Outside of that, there's always been other ways of event enabling S/4HANA and also ECC systems, and that is namely the event enablement add-on that SAP has OEM'd, which is built on the Asapio add-on that you can get from a small German company called Asapio. And there are plans to also provide something along those lines for advanced event mesh. And that will give you actually custom events all the way back to pretty old ECC systems. So in my opinion, all of these 3 event enabling options or the various flavors, is actually more if you count them, will be available, and you can pick and choose which ones you want to take, right? So if you just want notification events, you can just go with that. If you want to use the RAP approach and you are on one of the latest releases, then you can enhance your notification events. You can build your own custom standard events, and you can go with that. But if you are on older releases and you're not planning to move to the latest releases, that's when you should look at the add-ons, right? So the Asapio add-on and the SAP versions of that, which will help you even event enable much older systems. And that will also stay around for the newer systems. So that approach isn't going away. You just have more options in that space. Okay, hopefully that answered the questions here. Maybe one statement towards Kafka and other brokers like Event Mesh and Advanced Event Mesh. So generally, we see a trend here that you don't just use one type of broker. So Kafka is a very specific type of technology that is actually a log broker. So it works very different to some of the other event brokers that you find out in the market, like the Advanced Event Mesh. So the trend we're seeing here is that Kafka is more suited for analytical type use cases and similar things where you need to store a lot of data. And the Advanced Event Mesh brokers and similar technology is more suited for operational data. So real-time data distribution, where you need smart topics and filtering, where you want to have those real-time matching filtering capabilities, which you don't get on Kafka. So most businesses will end up having probably both type of technologies for the various use cases that they have. So analytics use cases, Kafka, operational type use cases, Advanced Event Mesh or something similar. But yeah, just do your research, read up on these topics. And if you want, you can also reach out and we can have a discussion on that. But SAP is connecting their S4 systems, which is primarily publishing operational data, to Event Mesh and Advanced Event Mesh. And it's also sort of supportability aspect here that comes into play. So it's quite hard for SAP to support a lot of different systems. You can always go via cloud integration if you want to connect to other systems as well. So there's also some options here. I think that's enough said on that matter. Paolo, do you see any other topics we haven't answered? Just browsing through.
I think you pretty much addressed all of them.
I think so too.
Yep.
Okay.
Okay. Well,
So we have some time left. If people still have some questions, they can still pop them in the chat. I'm just going to double check that I haven't missed anything else. Give people some time to pop some more questions in if they have, but yeah, otherwise, I guess we hope you enjoyed the session. You have learned something. I see there was a lot of interest by just the number of questions coming in rapid succession. So that's always a good indication that this seems to resonate with people and there's questions around that. So that's really good. Don't see any more questions. Paolo, you want to add anything?
Not from my side, just thank you to the audience. I hope you enjoyed the session and yeah, hopefully talk to you soon.
Excellent. Well, thank you very much, Christian and Paolo, for sharing your knowledge and expertise in this session. Well, you know, S/4HANA and event-driven architectures is a hot topic. That's why we had so many questions on the chat. So I also want to thank the viewer for joining the live event and taking this opportunity to make all these questions so that we can clarify your doubts about the subject. Or even if you're watching the recording of this, thank you for tuning in. There is plenty for everyone to learn during the Oktoberfest. So make sure to check out all the sessions that are part of the event. That's it. Thank you.
Thank you all.
Bye.